Hi, and welcome to this video. I'm going to assume that coming into this video, you already know about electron configuration and all of the background behind why each element has a specific electron configuration. However, in this video, I'm going to teach you a way to easily look at the periodic table and find out the electron configuration of any element. Now, this comes in handy not just with identifying elements, but also when you're learning about the periodic table, reactivity, and other important trends. So in order for this technique to work, I'm going to move helium right over here. So now helium is inside this little two columns that we have. Now I'm also going to divide up this periodic table accordingly. This first column, this middle block, and then this block. And remember in this scenario that helium is missing, and we moved it over here. And then this bottom section is going to be a block. You notice that there are actually a few empty spaces right here and here. And this has 15 elements. Depending on your teacher, you might want to put these two here, or you might want to put these two here. Personally, it makes more sense, in my opinion, to put the LU and the LR in these two positions. However, if your teacher says differently, you definitely want to go with what your teacher says. That means we're going to rearrange these elements. We're going to call this bottom block. We're going to remove these two elements, and we're going to put them here. If you probably remember from your chemistry class, H is 1s and He is 1s2. We have lithium as 1s2, 2s, and then so forth. These numbers actually come from the level inside the periodic table. So we have 1, 2, 3, 4, 5, 6, and 7. So in the first level, we have all the electrons, that's 1s2. And then in this one, you only have one electron, so that's why this is a 2s. But how do you remember which one's s, which one's p, which one's d, or which one's f? Well, that's where these sections come in. So this block is the s block. And that means all of the ending electrons there. So for example, in lithium, we have 1s2, 2s, 1. This ending one is in an s. So this section will always have s. This section here is the p section. So if we take something like boron here, we're going to go 1s2, 2s2, and then we're going to end here on 2p1. This middle section here is the D section. And something to remember with the D section is that it is -1. What does that mean? Let's see with scantium. So we have 1s2, 2s2, 2p6. We again have 3s2. Here we have 3p6. And note that I'm just reading down the periodic table. 1s2, it's the 1s, boom, 1s2. I'm just reading across the periodic table until I reach my element, 4s2. And then right here, you would probably say 4d1, but remember the -1. So instead, it's going to be 3d1. This bottom section here, this is the F. So if we take something like lanthanum here, would go 1s2, 2s2, 1s2, 2s2. We have the 2p6. We have the 3s2. Here we have the 3p6. Over here we have the 4s2. This middle block is 3d10. This end here is 4p6. We're going to go once more. We're going to have 5s2, 4d10, 5p6, and I'm just going to move the rest of this electron configuration right over here. We have 6s2, just reading down the periodic table, remember. And once we get here, we jump down because we do the F before the D. And this is highly dependent on your teacher. That's what I'm saying. Some teachers say that lanthanum is part of the D. Some people say that Lu is a part of the D. Right now, I'm saying Lu is a part of the D section, not the F section. But make sure to check on with your teacher to see what they want. This is currently a debate in the chemistry field, so you don't have to worry about that. So I'm going to do lanthanum based on what I'm saying that it is a part of the F. So that would be 6F1, right? Well, you know that D is -1, so actually F here is -2. So this would not be F41, this would be 4F1. You noticed how long lanthanum got? Well, scientists noticed that too. And they decide to develop a shortcut because we need a shortcut. So what they did is that they took this N column here. For those of you who don't know, this N column is what we call the noble gases. Noble gases are stable because their outer, if this is the nucleus, we have 2 electrons, we have 8 here, 7, 8. This is what we call a noble gas. This one in specifically would be neon because it has a full outer shell. And this is what elements are trying to accomplish. They want their electrons to have a full outer shell so they can be stable. So what scientists decide to do is that in order to categorize a specific element, for example, we want to categorize phosphorus, we're going to go to the last noble gas, so that'd be N here, Ne, and we would start reading from there. So we would put the noble gas, so that'd be Ne, and then we'll start right here, so that'd be 3s2, 3p3. And that makes things obviously a lot more efficient. If you want to, for example, say argon, you're not just going to say argon. That's not how this works. You will instead start from neon and then go all the way down. So that would be 3s2, 3p6. If you want to go for this one right over here, we'd go to the last noble gas, that's krypton. That'd be Kr. We're going to say 5s2 for D1. Because remember that D is a -1. So this is what we call the noble gas configuration. I'm just going to write config. So we have the full electron configuration, which writes out all of the things starting from 1s1. And then we're going to go all the way down to noble gas configurations, which is just taking the noble gas. For something like helium, there isn't a noble gas configuration for it because there is no noble gas right above it. So therefore, you would always use the full electron configuration. I mean, isn't such a big deal anyways because it's just 1s2. So I hope this video was helpful and helped you learn about how to recognize an element in the periodic table and identify its electron configuration, both the noble gas and the full electron configuration. See you in the next video.